Starting off with Chapter 7 homework, I'm going to work problem number 4. The problems in Chapter 7 have to do with confidence intervals. We're going to be using our calculator and the programmed formulas that are in that calculator. There's going to be a few of them that we'll have to use the formulas for, and we'll get to that in a little bit. But number 4 uses a pre-programmed formula in the calculator. So I read through this one and I notice that it's a regular confidence interval dealing with a normal. So what I'm going to be looking for is the z interval on my calculator. How I'm going to get to that is I'm going to push my stat button on my calculator. Then I will scroll over to tests. Then I will scroll down to z interval. I'll hit enter, and then I'm going to be on the normal distribution confidence interval screen, and it will ask me for several different entries. The first of which is it wants to know, are you going to enter in data in a list? That's where we would have entered it in L1. Or are you just going to use the statistics that were given? And that's going to be us. So you need to move your cursor over to the stats. And be sure that once you put it over there, move the cursor over to the stats, be sure and push enter so it knows that you're going to enter in those stats. And then you can scroll down and enter in your values. The first one it's going to look for is the population standard deviation. That's there at the beginning. It's right there. That would be a 100. Next, it's going to ask me for the x-bar, which is my sample mean. So my sample mean for this one, sitting right there, 84, 87. And then it's going to ask me for my n, my number of in this case modified bars, or a number in my sample, which would be 81. Then this calculator automatically looks things up in the table for you so that you don't have to, and it says what confidence level, what C level do you want. You will have to enter this as a decimal. I know that we want 90%, but you will have to key it as 0.90, and then you're going to hit enter for calculate. And then what it will give you is something that looks like, well, the answer that I have up there. I'm just going to do this. It's going to give you that, which you will just key in. The next question asks you, how do you modify the interval in order to obtain a 98% confidence level? How would we modify it? Well, really what we would have done was we would have changed our 0.90 to 0.98 because we used the calculator and the pre-programmed formulas. But just to make sure that you know how to look it up in the table, what you would do is, I've got a table all set up here, is I would look up 98%. There he is right there. Let me get my drawing tool. So my 98% is right there. This is a two-tail confidence interval, which is what we're looking for. We're wanting that two-tail, so it would be 2.326. Going back to our problem, let's see, I entered in 2.3 and they wanted it rounded 2 decimal places, so I just said 2.33, but you could have keyed in 2.326 and you would have gotten it. It's just you get that value off the table. The next problem I chose for you was problem number 8. Now the first part of this won't seem all that different. The first part is basically just like that I did in problem number 4, the previous problem. And so what I'm going to do is I'm going to hit my stat button. I'm going to go to, because it is a confidence interval on a normal distribution, so it's going to be a z interval. So I hit stat, go to tests, Then I'm going to go to z-interval. I don't have a list of data points. I'm going to enter in just the statistics that I've already calculated, or that they gave me actually. So I'm going to make sure the stats part of the calculator is highlighted. Then they want me to enter in the standard deviation. So the standard deviation for this one is 164.55. Next, they want me to give the sample mean, and that would be 654.16. And then the number in my sample, that would be 54. And my confidence level, C level. And this one, they want a 95% confidence interval, so I would key in 0.95, ask it to calculate, get those values. And what this means is that we are 95% confident that the interval contains the true population mean. Be sure and have a good idea of what this means. I'm going to have you repeat it on your test. I'm going to have you calculate a confidence interval, and then part of an essay I'm going to have you state what that confidence interval means. So be sure that you can differentiate between these and know which one to pick, because of course on your test you have one submission attempt. The next part is the whole reason why I did this particular problem. So on this next part you're going to need a formula. Alright, so here is the formula. I'm going to write it down for you. N, which is what you're having to do is you're having to figure out how many samples would you need, and then it's going to be 2, it's a 2 times z alpha over 2, meaning part of that interval, times the standard deviation divided by the width. And I'm going to go ahead and say that W is the width of that interval. Alright, so let's roll on this one. I've got 2 times, and now I need to go get this z value that I actually get from my tables. The reason why I made you look up that value in the table before. So I'm going to pull up that table and note that I'm looking for a 95% confidence interval. So let me pull up our table. 95% confidence interval. There he is. Now this table is in your Chapter 5 notes whenever I first introduced this particular topic, so just to let you know where it is. So that number was 1.96. We got that from our table. The standard deviation, they told me, although I've written over the top of it, is 172, and they want the width on this thing to be a 60 parts per million quantity squared. Now what you'll get if you crunch all these numbers is 126.27. Of course I can't have that many samples, so you always round up so that you can have the appropriate number of samples, and this would equal 127 kitchens. I chose number 10 because he was asking you to do a lower confidence bound. And that's a little different than what we were doing before. What that means is we're going to have to adjust our 90%, since this 90% actually goes 5 either way. Now what you're actually going to do is go 10 either way. So you'll do the exact same thing, but in order to trick your calculator and get that lower level, just use 80%, so that way it went 10% on either side instead of the 5. Other than that, it's going to be exactly the same. I'm just going to do I'm going to hit my stat. I'm going to use I'm going to hit test. It's going to be another z interval because this is a normal distribution. So z interval. I'm going to enter in my statistics. Now if I had a list of data, I would just put that in at L1 and then just say use my data. It really doesn't change it too much. My standard deviation for this is 1.5. Writing too fast. My x bar, or my sample mean, is 4.25. My n, or my number in my sample, is 75. And my confidence level, in order to get my calculator to do a lower bound, I just pretend like the sea level is 0.80 and ignore the upper bound. It's really, pretend that upper bound doesn't exist, because I'm just looking for the lower bound, and I'm just kind of tricking it into doing that for me. The next problem I'm looking at with you is a chi-square, and you will have a chi-square problem on your test for sure. It will be very similar to this one. You'll need to be sure that you have your formula handy, because chi-square is not done in the calculator. Well, I mean, the number crunching is, but just like the confidence interval, you don't have to use the formulas. The calculator does that for you. So what you'll need to do is have this formula handy, and know that in order to get a confidence interval for your standard deviation or your variance, that's what's called a chi-square. And you'll need to know what your degree of freedom is. That is your number of samples minus 1. So my degree of freedom for this one, since my number of samples is 8, my degree of freedom is 7. Something else you have to know is you have to be able to look up on your tables what your chi-squared value is. So for a 95% confidence interval, which is what we have, that means we have 5% to go either way on either side of that mean, which means I basically have 2.5% on either side, right? So if you're looking at on either side, so if I break that down in something that looks like a normal, that means I would have 0.025 or 2.5% over here, but then on this end it's 100 minus the 2.5%, so that would be 0.975, and that's what you're going to be looking up in our chi-square tables. So let me get that for you. Alright, so here we go. I'm looking at my degree of freedom. I said I wanted this 0.975, I think, so I'm going to need this number right here, because there's my degree of freedom 7, my 0.975, here's my 0.25, here's my degree of 7, so I need those two numbers over on my formula. Alright, I've written in the numbers for you. This is the chi-squared from the right, this is the chi-squared from the left. I know they're flip-flopped. The reason is because the less than, because I'm dividing by a big number, this number will end up being smaller, so he will end up being on the left. Because I'm dividing by a smaller number, it will make this number bigger. N minus 1, that's a 7. My standard deviation for this was 2.83 squared. Of course, if they give you the variance, it's already standard deviation squared, and you'll be fine, but this is the same on both sides. And then you'll just number crunch, and if you number crunch those, you'll see that you get these. Just take the square root to get your standard deviation. Of course, this is for variance, and then you'll get it for standard deviation. And that's how you work your chi-square problems. I'll let you crunch the numbers.